Have you ever stopped to think about the invisible magic that powers pretty much everything around us? When you flip on a light or charge up your phone, that's electricity at work. Today, we're going to pull back the curtain and take a look at the secrets behind this hidden energy that runs our entire world. Let's get into it.
I mean, think about it. It's something we all do, probably a dozen times a day, without even thinking. You walk into a dark room, you flip a little switch, and bam, the room is instantly filled with light. But how? What really happens in that split second? That's the mystery we're going to solve today.
So, here's our game plan. First up, we'll get to the bottom of what electricity even is. Then, we're going to put on our engineering hats and figure out how to build a path to control it. After that, we'll do a little detective work inside a classic light bulb, see how the modern LED totally changed the game, and finally, we'll decide which one is the true champion of light. Okay, first things first. We have to start at the very beginning. Before we can talk about circuits and all the cool gadgets, we need to answer the most basic question of all. What exactly is this electricity stuff? You know, it actually sounds more complicated than it is. Electric current is really just a bunch of super tiny particles called electrons, all moving in the same direction. The best way to picture it is like water flowing through a hose. The more electrons flowing, the stronger the current. And we measure that flow, that strength, in a unit called the amp, or just amp for short. So this river of electrons is what separates our gadgets from everything else. It's the secret sauce that makes a refrigerator work, but doesn't do anything for, say, a steel spoon. The electrical devices are designed to harness that flow and do something useful with it. While a wooden chair, well, it's just a chair. So where do we get all this power from? Well, it's all around us, really. We can grab it from the wind using giant windmills, soak it up from the sun with solar panels, and even use the incredible power of falling water. We can also generate it using fuels. They're all just different ways of creating that flow of electrons that we need. Okay, so we've got this awesome source of energy. But a wild river of electricity isn't much good to us, right? We need to build a path for it, a way to control it and tell it where to go. So let's figure out how we do that. Every path has a starting point, and for a small circuit, that's usually an electric cell. This is like the little engine that gives those electrons the push they need to get moving. You've seen these a million times. They're the little guys you put in your remote control or in your toys. Now, what happens when one little push isn't enough power? Well, that's when you bring in a battery. And here's the thing about batteries. A battery is just a team of electric cells all working together. They combine their power to give a much bigger push. Now, this part is super, super important. For electricity to do its job, it needs a complete closed loop to travel through. We call this path an electric circuit. Think of it just like a racetrack. The electrons leave the starting line, the cell or battery, and they have to make it all the way around the track and back to where they started. If there's a break anywhere in that track, game over. The flow stops. So, how do we control this race? With a switch, of course. A switch is basically like a drawbridge on our racetrack. When you flip a switch on, you're lowering the bridge, completing the path, and letting those electrons zoom around. And when you flip it off, you're raising the bridge, creating a gap, and stopping everything in its tracks. So, let's recap. If you want to build a basic circuit, you just need 4 key things. Number 1, a power source, like a cell or a battery. Number 2, wires to act as the racetrack. Number 3, an appliance, like a light bulb to actually use the electricity. And number 4, a switch to be the boss. That's it. All right, now that we know the rules, let's take a closer look at one of the first things ever powered by a circuit, the classic old-school light bulb. For more than 100 years, this was pretty much the only way people lit up their homes. I mean, it seems almost too simple, doesn't it? It's just a glass bubble with a bit of wire inside. So how in the world does it take that invisible electric current and turn it into light you can see? What is going on in there? Okay, let's trace the path of the electricity. The current comes in through the bottom, travels up one of the wires, and then it gets to the most important part, this super thin coiled wire right in the middle. That's called the filament. After it squeezes through the filament, the current travels back down the other wire and out the bottom, completing the circuit. That's a fantastic question, isn't it? The electricity is flowing through all the wires inside that bulb. So why is it just that one little piece, the filament, that glows incredibly bright? What makes it so special? Well, the secret is that the filament is designed to be a bottleneck. It's made of a special metal called tungsten, and it's really, really thin. So imagine all those electrons happily flowing along the wire, and then suddenly they have to squeeze through this tiny little path. It creates a sort of traffic jam for the electrons. This traffic jam is called resistance, and it creates an incredible amount of heat, so much heat, in fact, that the filament starts to glow white hot. And that's the light we see. But that glowing hot wire is old news. Today, we have something way smaller and way more powerful. Let's talk about the modern marvel that is the LED. All right, meet the new champion, the LED, which stands for light-emitting diode. These things are tiny, but they are absolute powerhouses. And their biggest trick? They are unbelievably efficient. They turn electricity directly into light without making a ton of waste heat. Now, an LED has one little rule that a regular bulb doesn't. The electricity has to flow in the right direction. It has two little legs, and you have to hook it up correctly. But don't worry, there's a super easy trick to remember which is which. The longer leg is always the positive one. Easy as that. And once you start looking, you'll see these things absolutely everywhere. All those colorful decorative lights you see during festivals like Diwali, yep, those are LEDs. And that super bright flashlight on the back of your phone, that's an LED too. Okay, so we've got the old school bulb and the modern LED. It's time for a showdown. Which one is really the better, smarter, and brighter choice? And honestly, it's not even a close fight. The old incandescent bulb is basically a tiny heater that just happens to give off some light as a side effect. Get this, more than 90% of the energy it uses is wasted as heat. That's why they get so hot you can burn yourself. But LEDs, they're the complete opposite. They're cool to the touch because almost all the electricity becomes light. That means they use way less energy, which saves money and is much, much better for our planet. So we've gone from a simple piece of glowing hot wire to a tiny, super efficient computer chip that makes light. The way we light our world has totally changed. LEDs are the clear winner today, for sure. But it kind of makes you wonder, doesn't it? What's next? What amazing new technology is going to be lighting up our world tomorrow?